Hey everyone, this is Atman and welcome to my midterm presentation on AI-driven security systems, a case study on CrowdStrike Falcon. Now, Falcon is one of the most popular cybersecurity solutions given out by CrowdStrike, used and is used by hundreds of companies worldwide to deter cyber attacks from their internal systems used for their various business use cases. Now, in today's digital age, cybersecurity threats have become increasingly sophisticated, posing significant risks to organizations and individuals. Traditional cybersecurity methods such as signature based detection are no longer sufficient to counter the advanced tactics used by malicious actors. This has led to the development of real time AI driven security systems capable of detecting, analyzing, and mitigating threats as they occur. Now let's take a look at this stats here. This indicates the the number of cyber attacks per continent, or should I say per region, where you can see North America being dominated by most of the cyber attacks. And also we can see by industry, the technology, telecommunications, financial, government, and retail sectors are the most heavily targeted by nefarious actors. Now, let's take a brief look at the background here of why we need cybersecurity solutions in the first place. Now, cybersecurity has evolved significantly over the past decade due to the increase in frequency and sophistication of cyber attacks. Traditional methods of threat detection, such as old antivirus softwares, signature based detections, they have limitations. Now, signature based detections rely on old predefined patterns of known malware to identify threats, which can now be trumped very easily by modern day cyber criminals. Now, with heuristic analysis, it uses rules to identify suspicious behavior, but often generates lots of false positives and lacks adaptability to new threat vectors. Now, with the rise of advanced persistent threats or APTs, zero day vulnerabilities, and polymorphic malware, there is a growing need for more dynamic and adaptive security solutions that can identify known threats. Now, CrowdStrike Falcon is a cloud native endpoint protection platform that leverages AI and machine learning to deliver real time detection, prevention, and response capabilities. The platform monitors endpoints for signs of malicious activity, analyzing data using advanced algorithms to identify potential threats. Key features of CrowdStrike Falcons include behavior analysis, where it monitors user and network behavior to detect anomalies that may indicate a cyber threat. Machine learning models, which might use supervised and unsupervised learning to classify threats and predict potential attacks. And scalability, which is designed to protect endpoints across different environments from on premises data centers to cloud based infrastructure. And integration with security tools basically ensures that it seamlessly integrates with existing cybersecurity tools such as firewalls, intrusion detection systems, and security information and event management solutions. Now, let's take a look here at one of the demonstrations of the CloudStrike Falcon's prevention of a cyber attack here. Now, this simulation was carried out when the CrowdStrike Falcon's auto quarantine feature was disabled. It means that whenever an adversary detected, sometimes threats are moved automatically to quarantine, but in this case, we kind of switched it off to see how far the adversary goes in order to compromise the system. But as we see, we let the adversary drop its malicious files, but it never got an opportunity to run it so that it could completely infect the current system. So as you can see, it drops 4 files, like a legitimate file in which the actual file it usually contains, and docs 2 nefarious discovery tools, and a ransomware. Now, when you see that when it tries to run one of those malicious discovery tools, that is where CrowdStrike kind of kicks in. And when the adversary detects that CrowdStrike has kicked in, it tries to open the control panel where it can try seeing what's going on. The Falcon Adversary Overwatch Alert kind of alerts all stakeholders that the threat has been detected. And once the adversary has come to the conclusion that the Falcon system has awakened and has stopped all its progress for the cyber attack, the adversary exits without causing any harm to the system. Now, let's focus on one of the core components of system engineering, that is the concept development. Now, let's look at the first part of needs analysis. Here, as cyber attacks become more sophisticated, organizations need security solutions that can detect and respond to threats in real time. Traditional security measures often rely on batch processing or post incident analysis, which delays response time and increases the potential for damage. In contrast, real time AI driven security systems like CrowdStrike Falcon continuously monitor network traffic, user behavior, and system activity to detect threats as they occur. This real time capability enables organizations to respond to threats immediately, reducing the potential impact of attack. Cyber threats evolve rapidly, with attackers frequently developing new techniques to bypass traditional security measures. AI-driven security systems must adapt to these changes by continuously learning from new data and refining their detection algorithms. Falcon uses machine learning models that are trained on diverse data sets, including known and unknown threats, to improve their ability to identify emerging attack patterns. This adaptability ensures that the system remains effective against the latest threats. Now, with the growing adoption of cloud computing, IoT devices, and remote workforces, cybersecurity solutions must be scalable across multiple environments. Falcon is designed to protect endpoints across different network architectures, from small businesses to large enterprises, and across various device types, including servers, desktops, mobile devices, and IoT endpoints. The platform's cloud native architecture enabled it to scale easily, accommodating the diverse need of organizations and providing consistent security coverages across all environments. Now, organizations must actually comply with a range of data protection regulations, such as the General Data Protection Regulation, just GDPR, and the California Consumer Privacy Act, that is the CCPA. Real time AI driven security systems must balance the need for robust security along with compliance requirements, ensuring that sensitive data is protected while maintaining privacy standards. Falcon incorporates privacy by design principles to ensure that its data collection, processing, and storage practices are compliant with global privacy regulations. Moving on to concept exploration. Now, this is where we proceed to do a POC or a proof of concept of the system that we actually intend to implement. Now, since this is an AI-driven security system, let's take a look at some AI and machine learning techniques that CloudStrike may or may not utilize to power its cybersecurity solution. Now, with supervised learning models, these models are basically trained on labeled datasets that include both benign and malicious activity. For example, a supervised learning model might be trained to recognize the signatures of known malware, phishing attempts, or ransomware attacks by analyzing wide range of features such as file hashes, IP addresses, URL patterns, etc. Supervised learning models can classify new data points and identify potential threats. And Falcon supervised learning is used to detect the known threats based on historical data. With unsupervised learning, its models are particularly valuable for identifying previously unknown threats, such as zero-day exploits or novel attack techniques. These models do not rely on labeled data. Instead, they use clustering and anomaly detection techniques to identify patterns in data that deviate from the norm. For example, an unsupervised model might detect unusual spikes in network traffic, unexpected logins from remote locations, or change in file permissions that indicate suspicious behavior. By flagging these anomalies, the system can alert security teams to protect itself against the potential threats that may not match any known signatures. With behavior analysis, Falcon continuously monitors user behavior, network traffic, and system activities to establish baselines for normal activity. The platform uses machine learning models to identify deviations from these baselines, flagging potential threats for further investigation. For example, if an employee suddenly begins accessing files outside their normal working hours or attempting to connect to restricted servers, the system will recognize this as a potential threat and generate an alert. Now, with reinforcement learning models, in addition to supervised and unsupervised learning, Falcon also explores reinforcement learning to improve threat detection strategies. It allows the system to learn from its interactions with the environment, adapting to response tactics based on the outcomes of previous actions. For example, the system might adjust its detection thresholds to or prioritize certain type of alerts based on feedback from security analysts, optimizing its performance over time. Now, Falcon also works alongside with firewalls to block malicious IP addresses and prevent network-based attacks. For example, when the platform detects a threat originating from a specific IP address, it can automatically instruct the firewall to block traffic from that source, preventing further infiltration. The platform integrates with intrusion detection and prevention systems to monitor network traffic for signs of malicious activity. By sharing threat intelligence and leveraging machine learning models, Falcon can enhance the effectiveness of IDS/IPS solutions, helping to identify and block potential intrusions before they reach critical systems. Falcon provides data to security information and event management systems, that is SIEM, for centralized analysis and reporting. This integration allows security teams to correlate data from multiple sources, identify patterns and trends, and generate actionable insights to improve overall security posture. The platform uses machine learning models to establish baselines for normal behavior, such as typical login times, file access patterns, and network traffic volumes. Any deviations from these baselines are flagged for further investigation. For example, if an employee typically accesses certain files between 9 to 5 p.m., but suddenly accesses them at 3 a.m., the system might well recognize this as a potential threat. Falcon employs algorithms like autoencoders and PCA to detect unusual patterns in data that may indicate malicious activities. For example, if a system detects a sudden surge in data transfers to an external server, it may flag this as a potential data exfiltration attempt. Anomaly detection techniques are particularly valuable for identifying new and unknown threats that do not match any predefined rules or signatures. Now let's move on to the final part, that is the concept definition. That is actually implementing and going and doubling down on our POC that we did previously. Now, for such a cybersecurity solution, setting a system architecture is kind of fundamental. Now, if you look at the prospective data collection and pre-processing module, it would be responsible for collecting data from multiple sources such as network traffic, endpoint sensors, and user activity logs. Data pre-processing involves filtering noise, normalizing inputs, and extracting relevant features for analysis. For example, the system might remove irrelevant data points, standardize timestamps, and convert raw log data into format suitable for machine learning models. The core component of CrowdStrike Falcon utilizes supervised, unsupervised reinforcement learning models to analyze data in real time. The engine continuously monitors for anomalies, suspicious behaviors, and known threat signatures, flagging potential threats for further investigation. For example, the engine might detect an unauthorized user attempting to access sensitive files and immediately trigger an alert. The incident response module would automatically trigger alerts and send out responses when a threat is detected. The response actions may include isolating compromised systems, blocking malicious IP addresses, and notifying security personnel. For example, if a system detects malware or an endpoint, it can automatically quarantine the affected device to prevent further spreading. Now, Falcon also provides a real-time interface for security analysts to monitor network health, review detected threats, and manage incident responses. The dashboard includes visualization tools such as graphs or maybe heat maps to help analysts and quickly identify and prioritize threats. For example, the dashboard may display a heat map of network traffic, highlighting certain areas of concern based on different threat levels. Now, moving on to the challenges of this system. The system must handle large volumes of data generated by network traffic, endpoint sensors, and user activities. Real time processing requires efficient algorithms and robust infrastructure to maintain performance. Ensuring high accuracy while minimizing false positives is a significant change. False alarm can lead to alert fatigue and reduce trust in the system. Continuous training and optimization of AI models are essential to improve accuracy and reduce false positives. Integrating AI driven security solutions with existing legacy systems can be challenging due to compatibility issues, data formats, and differing security protocols. This requires careful planning and customization to ensure seamless integration. The system must be scalable to protect different environments, including cloud, on premises, and hybrid networks. It should adapt to varying levels of complexity and scale to meet the needs of different organizations. Ensuring compliance with data protection regulations such as GDPR and CCPA is critical. Real time monitoring must protect user data and maintain privacy standards while effectively detecting threats. Ensuring transparency in AI based threat detection is essential to build trust amongst users and stakeholders. The system must provide explanations for decisions, especially in critical scenarios involving potential data breaches or malicious activities. AI driven security systems must balance the need for robust security with privacy rights. Over surveillance and excessive data collection can lead to ethical concerns and potential legal issues. Now, with the results and initial findings. Now, when such a type of a cybersecurity solution is deployed, like in the case of CrowdStrike with the current context, there is over 90% accuracy in threat detection thanks to these AI leveraged algorithms. And there is a significant reduction in incident response time due to automation. Now, there are certain areas there where our software could improve. The cybersecurity solution, the where it could actually improve, are in reducing false positives and enhancing multimodal capabilities. Now, the next step forward for such a cybersecurity solution would be to refine the AI models by incorporating attention mechanisms like transformers. We could expand data sources to include smaller embedded devices like IoT, multimedia, etc. And we can also improve transparency in AI decision making. Now, CrowdStrike Falcon is a cutting edge AI driven security platform. Now, we see that it makes significant improvements in real time thanks to reinforcement learning. Now, with such a perfect system, there are still challenges with maintaining scalability, accuracy, and transparency. Now, looks like the way ahead for Falcon would be to focus on refining models and enhancing integration. Yeah, thank you.